we'll start a little bit easier on this preview, at least I hope it is. Identify the transformations from the original log for the following graph. For example, are directions going left, right, up, down, and so forth? So that -2 and that -4, what shifts, what movements do they represent? I was going to say, this is what we did on that review refresher just last week, so I know you know. All right, so right 2 and down 4. This is always my left-right shift, and this is always going to be my up-down shift. And the only thing with the right-left is it's kind of the opposite of what we would think it's going to be. Good. Number 2, identify the amplitude and period for the trig function. Now this one I got to be a little more careful on. The amplitude isn't bad, but the period isn't just 4, because remember, my period, bless you, is always 2 pi over b, and that's my b value. So basically, I've got to do a little bit of math here, replace my b with the 4, and then reduce the fractional part. We leave the pi part alone, and we're set. So nothing too overly complex as far as that goes. And as we move to number 3, I'm going to give you a heads up. Every one of these questions where you see a formula given, they will be given tomorrow as well. So here at a town with a large convention center, the cost of a hotel room has increased 3.1% annually. If the average hotel room costs $42 in 1980, and this growth continues, create a function, in other words, an equation, that models the exponential growth of the room starting in 1980. Again, not solving. So, here's how my pieces work. When we're doing these, whatever I start with, whatever money or whatever it happens to be, is always going to be my A value. So that would be my 42. And really the only thing else that could get me here is when I get to my rate, I don't want to plug in 3.1, because if I did, that'd be like the equivalent of 310%. That'd be kind of pricey. How would I write this 3.1% in its decimal form? Yeah, 0.031. Because we're going to take this value, whatever it would be, and if I divide it by 100, that'll give me the decimal value if I forget. And then since we're just looking for a function, I'm just going to leave that t the way it is. Now, if they asked me, what would a room price be in 2016? I'd replace the t with 36, because it's 36 years after that, and so forth. But that's all I got to do. Okay, so we're going to keep life simple. Now, number 4. Before any of you have, an attack here and be like, oh my gosh, we've barely ever seen anything like this. Calm, because this is going to count significantly less than some of the other questions, but I do want you to know how to do it. So, there's 3 numbers here that I see I'm going to have to be able to plug in. So I'm going to have to be able to know what A is, what B is, and this K value that's here. So first, let's just see what they are, and then we'll figure out how to calculate them. So A is going to be my amplitude. We've had a lot of experience with amplitude, seeing, how far from that midline are we? How far from that center line are we? B is going to be my cycle value. How long does it take for me to get through my entire sine function once? And then finally, K is going to be my midline. And if it's been a while on that, we just find that by finding the value between the minimum and maximum. It's sort of like finding the average, or the middle. That's why we call it a midline. So once I find those 3 values, I'll be able to plug it in, I'll be able to graph it, and this will be cool. So let's kind of start getting some info and see what we have here. Okay, the depth of the ocean at a swim buoy reaches a maximum of 8 feet. So I know that's going to be as high as I go. And a minimum of 2 feet. Now, I will admit one thing. I do have a boo-boo here that we need to fix. I know, shocker, right? This is supposed to be 12 p.m., not 10 a.m. My apologies for that. So we're going to write a model based on that. You're like, well, if that's all the information I have, how am I going to figure this out? Well, a couple of things. First, we can actually find our midline at this point pretty easy. It's the value between the minimum and the maximum. So between 8 and 2 is 5, and that's going to be my midline. So we got that number. Then I got to stop and think for a minute. I'm like, okay, it says it's a sine function. Now, how does a sine function normally work? Normally with sine, I start at 0, then I go to the max, then I go to 0, then I go to the min, and then I go to 0. Okay? But this time, my center line, I'm not starting at the x-axis. My midline, or my starting point's at 5. So once I know my midline, I'm just going to replace those zeros with that 5. So I'm like, okay. So my first dot's going to be at 5. That's at 12 a.m. Now let's start seeing what we got here. It says my max would be next. My max is at 8. And that happens at 4 a.m. So you kind of see how my knowledge of a sine graph, plus knowing this information is going to help me. And you're like, okay, well then I go back to here. Then my minimum happens at 12 p.m. And that's down here at 2. And then I'd go back to 0. But I don't know what those other two times are. Or do I? Start at 12. Then I go to 4. If the pattern continues, what time would be next? 8, because you add 4. I add 4 again, and what a coincidence. 4 to 8 is 4 hours. 8 to 12 is 4 hours. And then I do it one more time to get my last point, which finishes my cycle. Okay, so my cycle is how long it takes to do one whole sine graph, and that's what this is. So to get from here to here takes 4, 8, 12, 16 hours. So my B is 16. I'll just kind of mention to myself it's the hours. And my amplitude is just how far is it from my midline to my min or max. So to get from 5 to 8 is 3. To get from 5 to 2 is 3. So my amplitude is 3. And you can kind of see how I can build the different pieces from the info I've got. So now I'm ready to go ahead and make my equation. So we've got A times the sine of BT, and again the T just stays the way it is, so we're flexible. And then plus my amplitude, and I'm ready to go. So it really isn't a terrible thing. It covers a lot of the things we actually did with the graphing. It's just written in a different way. Okay, so just remember what those 3 letters are, and we can work on getting to that. So as we flip over, identify the domain and range. Now technically these next 2 questions I could do without the calculator, but I am a fan of being certain with things. So I'm going to go ahead, I'm going to type this in, and I'm going to look at the picture. Now, I've got to keep in mind when I'm doing this that my domain and range, if I remember back, my domain is my x values from left to right. So I look at this picture, this graph, and I go, okay, well, it keeps going to the left forever. And if this little picture here kept going, this would keep going upward and outward forever. So every time on one of these growth problems, my domain's going to be negative infinity to infinity. That's just a given. My range, if we think back, goes bottom to top. So I go, okay, well the top goes up forever. So I see that that's going to be infinity. But it doesn't go down forever. It comes down and then it like levels off. What value do you think this is? -1, which I can steal straight from my expression. So if I see a plus or minus number here, that's going to be part of what my range is. So not a bad deal. Next one, I'm going to do a similar type question, except I'm going to get a little different information from it. So I graph this one. This one's decay. And when we're doing end behavior, remember, the x's are always negative infinity and infinity, sort of like the domain was up in number 5. And if we remember back to when we talked about these before, negative infinity is just like saying we're heading to the left, and positive infinity is kind of like saying we're heading to the right. So when I do these, and I remember that f of x is kind of like y, I go, okay, so as my x value is going left, what's happening to y? Well, y is going to go up, 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 up forever. It's going to go to positive infinity. So basically this says y goes up as x goes left, and that's true. So then I do it the other way. As we go to the right, what value does y approach? Not infinity, not in negative infinity, but 0. Y approaches 0 as x goes to the right. And that's all there is to those. But the easy part to do with this is just remembering that x is always the infinities, and then the only one you really got to think about at all are the y's. So that'll make life a little bit simpler, I hope. 7, sketch 2 cycles of the graph 2 sine theta. So normally we get our 5 lines. We're starting at 0. I notice my amplitude is 2. So I get my max and my min ready to go. And then like we just mentioned on the other page, normally we go 0 max, 0 min, 0. But I need to label my axes first. So I know my period is 2 pi if I don't see a number in front of here, which would divide it down. How do I get the other 3 values down there, though? What's a way at least I could get this one in the middle? What's in between 0 and 2? 1. There we go. Okay. So 1 pi in the middle. And then between 0 and 1 is a half, or pi over 2. And so for the rest of these, and even when we extend this out to the second cycle, remember, there's a pattern. We're just going to keep adding a half each time as we go. Pi over 2 is 1/2. 2 over 2 is 1, or 1 pi. 3 over 2 doesn't reduce. And then we have 2 pi. And then I just got to remember my pattern, which again is 0, max, 0, min, 0. And that would take care of my first cycle. So now to extend it, I've already got my first line, so I just need 4 more. It's kind of like I'm starting back over at 0 here again a bit. And if you're not sure on the values, just keep adding the 1/2 through, just like you were before. 5 over 2 doesn't reduce. 6 over 2 does, that's 3. 7 over 2 doesn't reduce, but 8 over 2 does. And so then I just start the pattern again. 0, max, 0, min, 0, and I have covered my 2 cycles completely. So it's just taking your knowledge and expanding it a little bit. So nothing too bad there, nothing too bad. Okay, now 8 looks nasty, but it's actually really easy. The pressure against the walls of blood vessels of a certain person is given by, and they give you this big, ugly-looking, fancy cosine function, where t is the time in seconds. If 1 cycle is equivalent to 1 heartbeat, what's the person's pulse rate in heartbeats per minute? So if this is in seconds and this is per minute, how many seconds are in a minute? 60. So my t is going to be 60. Because if we're talking in minutes and this is in seconds, we'd need to go by 60. So there's 2 things I got to watch out for. One is I need to make sure I'm in degree mode. If my calculator's in radians, I'm not going to get the right answer. And the other thing I have to be careful of is the way I type this in my calculator, which we're going to do here momentarily. So what I've listed there right now is the way I'm going to type it in first, which is actually the right way to do it. And I'll show you what happens if you do it the other way. And I think if you actually saw this on the post and you did what I'm about to show you in a minute, that you'd be like, wait a minute, something's not cool here. Oops, and I almost did the boo-boo. Okay? All of it in the parentheses. Oh, I better make mode. Okay, I'm in the right mode. I had to make sure. Oh, what did I type in? Oh, I see what I did already. Dang it, I was doing so good on this. It's like it's kind of important when you're doing a cosine function to actually type cosine in. That's usually helpful. So let's try that again, because that answer I had before didn't make much sense. Okay, let's try again. That's better. 115.9 heartbeats per minute. Now, let's say when I was doing this, I made a boo-boo. Not like the one up there where I completely forgot cosine. That's a little over the top. But let's say you're looking at this and you're like, all I see that should be in the parentheses is the 8 pi divided by 3. So you do that, and then you do your times 60. Now, I would hope you would look at that answer and go, 1,087, negative 1,087 heartbeats in a minute. First, if your heart's beating that fast, you're probably dead. And second, if it's negative, that's a whole other problem. So hopefully you'd keep messing with that a little bit. But easy enough, just keep everything in the parentheses. All right, so we'll get away from the graphical stuff here for a bit. Next, we're going to do some simplifying. 2 possible issues here. What's a possible issue that could screw somebody up doing this one? Divided. Okay, so what do I have to do when that's divided? Got to flip it. And one more thing while we're at it. What can I do to this? Factor it. Okay, so what's that going to look like with a difference of squares when I factor it? Nice. 2x plus 3, 2x minus 3. If you avoid those 2 pitfalls, life is easy. Because now I can cancel the things that are identical. The x plus 4s, the 2x minus 3s. Again, it has to be 1 in the numerator, 1 in the denominator. And then let's see what we got left. So my last question then on this one. Can I cancel the x's? No, they're bonded. Okay, that plus is bonding them unless I see something identical with the parentheses. That has to be left alone. Unless you want to see me writing ah on your paper. Which I'm sure will happen a place or two. I'm just saying. Okay. Number 10. Another one of our favorites. Adding fractions with uncommon denominators. Again, when you're looking for these, we look for single variables, which we don't have here, and then we look for sets of parentheses, and every single different set needs to be part of my LCD. So in the past when we've gotten here, we've talked about building your fraction, okay, building your numerator. Once you get your fractions written out with your new denominator, remind yourself, oh yeah, what do I have to do to get from here to here? And we've been checking off the ones that we have. And whatever doesn't get checked off is going to be the piece that I need. Now once that's done, think there's only one more thing that could screw us up. So hopefully, notice I'm not canceling anything right now because that'll get me back to the beginning. So we're going to do all of our distributing at this point. And then I just got to combine up in the numerator my like terms to get this simplified. And we're going to be set. But it all comes down to, do you find the right common denominator, and go ahead and build that. So not a bad deal, not a bad deal. And again, one more key for tomorrow, one kind of hint as we're going through here. Pace yourself well. If you get bogged down on something, like you forget how to do number 10, you're like, I know I got to do something, but I don't remember. Skip it and go back, because again, your time, you've got to get done in that period, so make sure you're on that. Okay, formula given. You deposit $500, so that's what I start with, in a savings account. For each year thereafter, you plan to earn 15% more than the previous year. Okay, so 1 plus, remember, got to have the decimal form of my percentage. How much money will you earn in all after 20 years? So I have a time this time. So I'm going to go ahead. I'm going to get this typed in. And find out I'm going to have myself a nice little chunk of change here after 20 years. Not too shabby, not too shabby, not too shabby. And then I'm off to the next thing. So not all of these are going to be real deep, dark, and complicated, just the occasional question. Okay, 12. Notice we're doing adding again, and we're supposed to fix the mistake. Now this is going to sound strange to do at the start, but just stay with me. I'm going to cover this up right now. I don't even want to look at theirs. I'm just going to do it myself and make sure I do it right, and then I'll see what they did wrong. So, first question on this one, what's my LCD going to be? I tried to put in the parentheses a little bit of a help. We talked a bit before about how if there's any single variables that aren't bonded, that's part. And then any set of parentheses that you have is going to be the other part. And now, just like we did on the last question, it just becomes a big game of build it. I got the x plus 3. I just need the x. I got the x. I need the x plus 3. So I keep that denominator, and this time I'm going to go ahead and do the distributing and combine like terms in one step. So even though I'm distributing over here on the right, 5x plus another 5x is 10x. 5 times 3 is 15. And again, I don't see anything that cancels, but normally it's a good idea if you see something that factors out, even though we're going to find out that answer is fine. If I see something they have in common and factor it out, I should, just in case something simplifies more. But I would take either of these answers. So that's my correct answer, but there's one more piece to this one. So even if you just figure out that part and then leave the description blank, at least you'll get some points. Now I can look at this person's. What did they do wrong? So there's a couple of directions you could go with this. What's one thing you see in the person's attempt at this that's different from yours? I can tell they're not this. Right. There's a couple of things going on here. First, they don't have the right common denominator. And you're right, they didn't even end up with that x over here with that one because they forgot to get that multiplied in. Okay, they just assumed the LCD was x plus 3, so they just had to multiply by 3. That was kind of silly. You might even be able to say they multiplied by 3 here, and that's add 3. So you do have some options on explaining that. But that's just a couple that we could kind of take on there. But again, the main thing there is getting the right answer. All right, logarithms. We were just doing this on the refresher last week. I need to get that log base 3 out of there so I can solve for x. How do I dump it? The opposite of log 3, it's the big fancy mathematical term. We're going to exponentiate using that number, whatever this number is. Because those are inverses, so that would get that out of my way. And again, exponentiate means the side becomes an exponent. That's 3 to the 4th power, not 3 times 4. So that's going to be 81. And then I just add the 2 to finish her off. And I'm ready to roll. Okay. And I'm going to do something similar then again with number 14. Except now this time, instead of the log being here, it's the number I need to get rid of, but the inverse works the same. So this time I'm going to use the log to get rid of my 2, which is in my way. Now the other side, this gets a little more interesting. I have log base 2 of 8. And we talked before when we were doing these about this thing called change of base, which basically means you take the log of that physically larger number, the one on the right, and you divide it by your little base number. And you've got to do them separately. And then the log goes away. Now you just have a number to work with, which is nice. And if you get a decimal sometime, that's okay. You just work with it. And now it's just an Algebra 1 equation. I add my 2, divide by 3, and if it doesn't go in nice, well, we just leave it as a fraction. I wouldn't scream if you put it as a decimal, but the fraction is nice. Okay, 15, don't overwork. Consider the equation. What are the excluded values? What are the values that make the denominator equal 0? And notice there's 2 blanks, which probably tells you there's going to be 2 of them. So the only part I care about in this problem is that part. What are the numbers I could plug in for x that make it equal 0? One of them should be fairly obvious. 3. How do I get the other one? That second one looks factorable. X times x is x squared. 3 times 3 is 9. So 3 minus 3, but what do I plug in here? I just set that equal to 0. Go, oh, negative 3. Okay. That's not too bad. So a lot of this, I'm hoping, as you do it on here, it's just going to kind of start returning us to a place that we've been before, because we've seen this before. Especially this next one. I think someone said earlier in the day we've seen this 10,000 times this year. Well, if we have, this should be simple to work with. So here, I'm going to get to my y equals, because it's going to make it go the fastest. And I'm going to type in the 2 expressions that I have available. If I actually type them in correctly. Keep having these malfunctions with this. All right. So luckily the expressions are given to me. And remember, I'm going to look at these, and I notice the question down below, how many years later will the salary from Wallaby Corporation, my second column, exceed the salary from Campos? So I look and I'm like, okay, no, close. Yes, here. Column 2 is now bigger than column 1. 5 years later. Which offer is best? You can explain either one and be correct, but you have to have good reasoning. Now, personally, my reasoning would be Well, be because after 5 years I make more. I mean, if you're going to be at a job for 30 years and 25 of the 30 years you're making more money at this place, that's a good deal. Now, if you said can't go because I'm moving in 3 years, or can't go because I like to leave my options off, whatever it happens to be, you can argue it, but you've got to make sure you have a good reason. Just saying. Okay. 17. You want to know how students and parents feel about team-taught classes. Determine the following situation calls for a survey, an observational study, or an experiment. Which one? Survey. Because it's how we feel. You know, what do they think? What's their opinion? That's a survey. If I'm just watching them, it's a study. If I'm doing something to them, it's an experiment. Speaking of, you want to survey a sample of your school student population regarding the cheating policy. Describe how you administer the survey. Justify that your process is random and unbiased. So if I wanted to do a survey on cheating, how do I go about finding my people to ask? There's lots of options. We could survey every student. What if we didn't have time to get to all of them? What would be another option? What's that? Okay. We could have computer selection. That would work. Okay. If we were going to be human ways, maybe we do like every 10th student that you see on the roster, you're just like, I'll take this one, I'll take this one, I'll take this one. Because then you never know what you're going to get. That's pretty random. Any of those would absolutely work. So again, it's one of those questions, as long as you just think about it a little bit, you'll be fine. All right. We're rolling. For a statistics project, a group of students decided to collect data in order to approximate the percent of students who drive to school. They collected their data by interviewing all the sophomores in the school. Was this a good method of sampling? Normally when you ask that question, the answer is going to be no. Explain a better method of sampling if you feel this method was inappropriate. So if I want to see the percent of people who are driving to school, and I'm not just asking all the sophomores, probably a bright idea, what would be a better way to get a feel for that? What groups might I want to talk to? Or what info? Yeah, so maybe I survey juniors and seniors. I like that idea. That's the one I'd thought of. Somebody earlier said, and I think this is a good idea too, so we're going to put it down, you could check on the number of parking passes that got sold. You could break it down by age. You could break it down by numbers. You could do a lot of things with that. So I think either of those are a really good method of going about finding that answer for you. All right. Finally, we are going to hit something, again, that is more recent, even though our surveys and experiments are recent. Here come the charts. Okay. This is some issues we'd had on the quiz. So I'm hoping if some of you missed some of these, you'll see it now and it'll clear some things up for you. Probability of underweight in male. This is one thing that's going on. It's not two things being added together. Okay, that's when we see an or in the middle. And it just means I go to the underweight and I go to the male, and whatever number it is, that goes on top. And then I look for the grand total because there's no given. The grand total is 112. And of course I reduce the fraction. So that's just straight pluck one number, put it over the total, I'm done. That's classic probability. For the last two though, I got to think a little. Female or overweight. Okay, probability of being female, there's 46. Overweight, find that column, find the total. 72 out of 112. But then I run into a problem. Because if I add these up, I get 118 over 112, and I can't have over 100%. That's kind of ridiculous. So here's what I got to ask myself. Is there any overlap? Is there any repeat in there if you're female and overweight? Well, yeah, the female overweight people. So female overweight is 24. So I have to take the overlap part back out. Then I get an answer that is more within my limits. And I'm set for that. And then our last one up here, there's our fancy word given. Okay, it also could be written overweight / male. So what's that mean? Well, I want the overweight males, the combo, over what's after given, which is just the males in general. So let's see, overweight males is 48. Total males, heading this way, is 66. And we just reduce the fraction down. But I've got to remember that whatever's after given is my denominator. I can't flip those or I won't get it right. And I'll probably get something over 100%. All right, 21. Music company reviewed 3 surveys of people's music type preferences. One survey reported of the 150 question 32 preferred country. A second survey noted that 32 of 160 surveyed liked hip hop. A third survey found that 28 out of 75 preferred rap. If the music company were to choose 2 types of music to promote, which combination would draw the greatest number of fans? Okay, here's my theory on this. So I got country, I got hip hop, and I've got rap. And if I take each of those and turn them into fractions, so 32 out of 150, 32 out of 160, 28 out of 75, and I just punch those in the calculator and get the decimals out for all of them, because decimals are usually pretty easy to compare. So I'll write these down. If I want to find the combination, the pair that would get me the greatest number of fans, you just looked for the 2 biggest decimals. Looks like country and rap win. And that's it. Okay? That would get me my greatest number of fans. I don't have to figure out every combination. I just need to see which combo would be the best for me. And finally, we get down to 22. Now, watch it on things like this, because I have a question up here in the top, and sometimes people forget that. Hopefully we don't. Survey asked 50 people where they learned about school events. What's the probability the person gets the information from friends, given that the person is female? So, friends who are female, put it together, over what's after given, which is females. So let's see if I have all this info given to me already. Female friends, that's 9. Females total. I don't have a total this time, so I have to do it. So 17, 19, 26. And that doesn't reduce anymore. And then our last question down below says, AJ calculates the probability as Facebook given female is 8 over 11. AJ is not correct. What probability did he calculate? Well, we'll come back to that. What's the correct calculation? So again, put the 2 together. So female Facebook over whatever's after the slash, whatever's after the given, which is females. So female Facebook is 8. Female total, we said, was 26. And I reduced that down. And I'm like, okay, now let's look at what AJ did here. AJ got the 8 right. So that's good. So he had the female Facebook group up in the numerator. Where do you think he got the 11 from? Something to do with female and Facebook. I think so, because if you look at Facebook, 8 and 3 is also 11. So he got this backwards and thought you divided by Facebook. He got this mixed up that it should have been the females. So that's something else that we're looking for. Now, like I said before, this is the post. I changed some numbers around and maybe music preferences and some of the wording. But this is what you've got working. So when you come in tomorrow, once you get that, Sit down, get after it. All the formulas are on here. Grab a calculator. You won't need anything else. You won't have any other formulas to do. It'll be the only thing we're doing tomorrow. So let's get that set then.